Assalamu alaikum. I hope everyone is having a nice day. My name is Muhammad Kaptoor, and this is physics for grade 11. We will be discussing today Newton's laws of motion, which is a revision for what we have studied in grades 10 and 9. By now, you know all of Newton's three laws of motion, and for who does not know who Newton is, he is a mathematician and a physicist from the 17th century, and he formulated the laws of motion in a very simple and consistent way. Uh, these three small pictures represent the laws of motion, the three laws of motion. Uh, I want you all to pause the video for a few seconds and try to remember what these are and what you know about them and what examples can you give me about them, so I can know all your thoughts about them. And let me say something that interaction between students and the teacher is an essential part, and I should understand what you understand so we can continue upon that. Okay, let's continue. Let's start by Newton's first law of motion, the law of inertia or inertia. There's two pronunciations of this word, which states that an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted upon by an unbalanced force. So here we have a number of things. One is, what do we mean by unbalanced force? If we have two people pushing a rock from one side, this is an unbalanced force. If I have the same force from both sides, they will cancel each other and the rock will not move. This one will move, this one will not move. And the law here states that if there's no forces acting on an object, or the sum of the forces is zero, then the object will not move. It will stay at rest. And if it has a speed, a constant speed, it will remain at the same speed forever. So let's imagine you have something like a rock floating in space, and you want so if there is no forces acting on it, it will stay where it is, or it will continue moving forever at a constant speed in a direct line. Here we have another picture with a football. If there's no forces acting on it, then the football will stay in its place. Actually, there's two forces acting on this football and this rock, which is the force of gravity and the reaction of the surface, and they cancel each other. So the football remains in its place. Now, if you kick it, it will move. You give it some speed. It will continue for the same speed forever, providing that we neglect air resistance or air drag on the ball. Now, it will not stop until such time there is another force that will make it stop, like the net here, to apply a force in the opposite direction that will stop it. So this tendency to resist change in a state of motion is called inertia. This is the definition of the word inertia. Now, let's give some examples. I want to hear another examples from your side also. A soccer ball will not move until it's kicked. A golf ball continues to roll until friction and gravity stop it. A pencil on a table will stay there until someone picks it up. So these are examples of the application of Newton's first law of motion in our daily life. Now let's this particular picture, I took it from the internet, and uh, the person who wrote it made a small mistake. I want you all to pause the video and tell me where this mistake is, if you can. Now I will make it easier if no one have spot the mistake. It's in the second statement. Again, I suppose you stop the video for time and have some time to think about it. It's the gravity. The golf ball will continue to roll until friction stops it. Gravity has no role whatsoever in stopping the ball. If you don't know why, that's another discussion. Let's go to the next slide here. Newton's second law, force. Now, the first law says that nothing will happen until we act on it with a force. No movement, no change in movement will happen until we act on it with a force. Now, this law relates the cause of the motion, which is the force, and the result, the effect on the object, which is the acceleration. What happens when we actually apply a force on an object? It will gain speed, or it will reduce its speed. So there is a change in speed or a change in direction. And that's what we call an acceleration. So the acceleration of an object depends on the mass of the object and the amount of force applied on it. This equation tells us that an object subject to an external force will accelerate, and that the amount of acceleration is proportional to the size of the force. The amount of acceleration is also inversely proportional to the mass of the object. Now, so we have F represent the force, mass of the object to the body, and acceleration of the body. Let's further analyze this law, because it's very important in solving problems. This is the part where calculation happens. So the first force applied on an object is equal to the product of its mass and acceleration. If we rearrange this equation, we can have acceleration on one side and force divided by mass on the other side. So if you need a large acceleration, you either increase the force or reduce the mass. You have the same, if I have a force, I have certain mass, I have a certain acceleration. If I use more force, I will have more acceleration. If this force remains the same as the first one, but I have more mass, I will have less acceleration. Okay. So this is how we can understand and apply this force in problems and problem solving, which will be the subject of the following lesson. Newton's third law of motion, action and reaction. So whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first one. Examples: when you fire a gun, you are firing a bullet in one direction, the reaction will be the recoil of the gun. When we walk, we actually using action and reaction force. When you step on the floor, this is an action. The reaction is the floor pushes you forward. If there is no force of friction between your leg and the floor, let's say you are standing on very slippery ice, there's no friction whatsoever, so you cannot have a push forward, and if you try, you will most likely fall down on your face. So be careful. Another example is this boy when he was on this boat, so he jumped to the wood deck here. So the boy's feet exerts a force on the boat. The reaction of the boat is pushing the boy forward. So the boy goes forward and the boat goes backwards. I want all of you to give me more examples if you can. Well, uh, look, these three laws of motion is the basis of all motion you see around you. So the examples are all around. The examples of the first, second, and third law. You can every motion you see is governed by these laws. Every uh, industry, machinery, airplane, car, whatever, they are all governed by these three laws. So uh, the examples are endless. Everything in your life depends obeys these three laws of motion. So that's why it's very important to study them, understand them well, so we can go forward with studying special cases this year in grade 11. We have vibrations, we have wave motion. We will also add two very important principles later on, the conservation principles of momentum and energy. That will come later. Now, I want to give you a small video. It's about 7 minutes. It represents the Wright brothers, which these two inventors invented the first airplane. So this is a small movie that shows these two people, these two inventors, talking about how Newton's laws of motion apply to their invention. It's very interesting, and I will ask you uh, uh, how exactly they applied the first and second and third laws of motion, Newton's laws of motion, to their uh, design of the airplane. So pay attention, please. Yeah, that's, I need to share the other screen. Just a moment. This one. Let's share the actual screen. Yeah, YouTube, you need to skip the ads. Oh, oh, exhausting. Can you believe that? Get rest. Or if object's in motion, it can stay in motion, unless it's acted upon by an external force. Well, our airplane trying to take off is a perfect example of that. The airplane's at rest at the end of the rail. We apply an external force when we turn the engines on, action, reaction. And that's all Newton's third law. So maybe the way I can make more thrust here is so I suppose you all saw this short video and you can answer these questions. Let's move on. Now we will go to another fun thing we can do to further deepen our knowledge and understanding of Newton physics laws of motion. We will use a simulation done by the PhET project, which is done with is, uh, first introduced by the University of Colorado. There is a lot of simulation there that can help you with physics, mathematics, chemistry, and biology. Now, let's go to this particular simulation. And I want you all to try it, try different scenarios, play with it. Let's go to that screen. Yeah. So this is a simulation of how we can apply forces and how they produce motion. So this is an object at rest. If you put equal forces on both sides and you try it, nothing will happen because you have the sum of forces is zero and there's no acceleration. If I add if there's a net force acting on the object, it will gain speed and it will start moving. Okay, so we can play with that. We can also try motion. What happens? How speed is changing? Then apply a certain force for a certain time. While applying force, the speed increases. If you stop, the speed will remain the same forever. You can try different scenarios, increasing what happens if you increase the mass of the object. If you want to stop it, you need to apply a force from the opposite direction to slow it down, and things like that. You can also do experiments with friction, adding friction to the simulation, and you can also see what acceleration you have when you do these kind of experiments. So let's see how much acceleration I have. You can calculate that using Newton's second law of motion. Because there is friction now, it's slowing down. Yeah. So I want you all to play with it a little bit here and at home, try different scenarios and see what question you can came up with. Let's go back to our original lesson here. Yes. Next slide. Let's review Newton's laws of motion. Newton's first law of motion, inertia. An object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless acted upon by an unbalanced force, like this shopping cart. If you leave it, it will stay in its place. If you push it, it will go in a constant speed forever if there is no friction. Newton's second law of motion, force. What happens when you actually apply a force? How much movement you get? So the acceleration of an object depends on the mass of the object and the amount of force applied. If you push an empty card or a full one, you will have different responses from them depending on the mass. Newton's third law of motion, action-reaction. When you are pushing the card is pushing back. Let's say you are on slippery ice and there is no friction. When you push the card, you will also be pushing yourself backwards. Okay, so this is a quick review of Newton's laws of motion. I hope you all enjoyed the lesson, and if you have any questions, please ask, and get you all. Thank you very much for listening.